everyone, and welcome to our first video about genetic algorithms. Previously, we've read an article and discussed the basics of genetic algorithms, and in this video we're going to see an in-depth, step-by-step of the procedure on how to implement a genetic algorithm. So our first step is to represent our variables as a chromosome with fixed length. So we're going to say that our variable today has a length of 4, and these will be bits, so zeros or ones. We then need to choose the population size, or the number of chromosomes in each generation. So I want to say that n equals 6 for this case. Next, we need to choose a probability of crossover. So we're going to say P sub C is equal to 0.7. And finally, we're going to say the probability of mutation, P sub M, is equal to 0.01. The length of our chromosome is generally going to be defined by our problem. N, P sub C, and P sub M are all going to be parameters that we can choose that will have a rather large impact on the performance of our system. Step 2 is to define our fitness function. So for this case, we're going to say that our fitness function, f of x, is equal to 15x minus x squared. So we're going to take our chromosome that's in bits, convert it to decimal form, and plug it into this fitness function. We're going to be maximizing this function. We then need to randomly generate our initial population. So we would randomly pick a series of zeros and ones. So we start with our first chromosome, x1 sub 1 for the first generation. And let's say that equals 1, 0, 0, 1. We then do this all the way out to x6 for the sixth chromosome. Our population equals maybe 0, 0, 1, 1. Step 4 is to calculate the fitness function of each individual. So again, we would convert these binary numbers into decimal numbers, and then we would calculate fx1 sub 1, again, all the way out to f of x6 sub 1. Now that we have these fitness values, we go on to our next step, which is selecting a pair of chromosomes for mating. We do this by creating these probability percentages of selecting them, which are based on how fit they were. So chromosome 5, that had the highest fitness value, has the highest percentage or the highest probability of being selected. So what we do is we pick two random numbers, and we then use those to select our parent chromosomes. So say we selected x1 sub 1 and x5 sub 1 as our two parents for mating. In step 6, we now create a pair of offspring, or children I'll refer to them sometimes, using genetic operators. So first is crossover. So we pick a random number, and we compare this to our crossover probability, P sub C. If this number is less than the probability, then crossover occurs. If it's greater than the probability, crossover does not occur. If crossover does occur, we pick another random number to determine where that crossover point is. Details of this will be covered in our next video. We then perform the operation of mutation. So again, we pick a random number, and we compare that to P sub M, or our probability of mutation. Again, if this number is less than P sub M, mutation does occur. If it's greater, it does not. If mutation does occur, we pick another random number to select which gene mutates. Once again, details will be in the next video when we run through an example. From this, we create our offspring, which we denote as x1 sub 1 prime and x5 sub 1 prime. In step 7, we now place these newly created offspring into the next population. So we have x1 sub 2, 2 for the second population now, and that's going to equal x1 sub 1 prime. And we have x2 sub 2, and that's going to equal x5 sub 1 prime. Step 8 is to now repeat steps 5 through 7 until we have a full population. We only have 2 members of our population now, and we need 6. So we go through, we select new pairs for mating, we create offspring, and we put them in. So we would have x3 sub 2, x4 sub 2, and then we'd have to do this one more time to get up to our 6, creating x5 sub 2 and x6 sub 2. We now have our full population of 6, and we can move on to step 9, which is to take this population and use it to replace our initial population and continue the process. So step 10 is now continuing the process. So we go back to step 4, which if we remember was calculating the fitness value. So we would calculate f of x1 sub 2 through f of x6 sub 2. We would select our new mating partners based on that probability again, perform the genetic operations to get offspring, put in a new population, and continue until our stopping criteria is met.